Hi all. So today we will talk about sampling design and survey weights. So there are different types of sampling designs, which are basically types of probability sampling. So first is simple random sampling. Simple random sampling includes randomly sampling individuals from the population, and this is done so that we reduce the error in the data collection. Also, in this particular type, it is assumed that it is for the conventional statistical analysis. So any type of data that you see, most of the time, whenever it's a secondary data or even a primary data, for any kind of conventional analysis, we assume that this data was randomly selected. There was random selection of individuals from the population. However, this random sampling method, it does not assure a representative sample of your general population. So if your target population is, let's say, a minority group, then even if you do simple random sampling, there is no surety that your particular sample is a representative sample of the minority group. So this is what simple random sampling looks like. So let's just assume that this is the general population and you are trying to do some random sampling of individuals. So this is what it's going to look like, where you just pick up individuals by chance. And when this type of sampling happens, we cannot be sure that it is representative of the sample population. However, in this type of sampling, it is always assumed that this is for a conventional statistical analysis. Second type of sampling is stratified sampling. Stratification is nothing but basically grouping of individuals. So this population is divided into groups, and within each group or within each stratum, we randomly sample participants. So doing this, we are assuring that it is more representative of the population, and in this type of sampling, there is more precision and less error compared to simple random sampling. So this is how it looks like. So if you're collecting data from an elementary school wherein there are different grades of classes, grade 1, grade 2, and grade 3, so this is nothing but stratification of those elementary school children, wherein you are stratifying them into different groups, which would be even class 1, class 2, and class 3. And then within those classes or within those grades, you are further randomly selecting participants or randomly selecting those school children. So this kind of sampling is a little more representative of the population, and there is more precision and less error. And lastly, coming to cluster sampling. So cluster sampling is again a random sampling of groups, but these groups are naturally occurring groups. And one example, as we saw previously, is classroom, because all kids who go to school, they are in a particular grade because they are all of the same age group, which means these are more similar individuals. Therefore, there is decreased statistical precision in this since they are more similar to each other. So this is an example of cluster where we are clustering those population or those participants into a particular group. So let's say this is your population, and now you want to go ahead and do some cluster sampling in this population. So what you will do further is you will divide this population into different groups, right? So each group over here, you can see, has 6 participants. So let's just assume that these are classes, and each class has 6 students in it. And now that you have divided this particular population into different clusters, you further go ahead and do random sampling from these groups. So you randomly select, let's say, out of all these, you select 3 groups over here. And now within these 3 groups, you're again going to randomly sample class students or randomly sample your participants. So this way, you can go ahead and randomly select some participant from that particular cluster which you have selected, and you can do that for the remaining also. So over here you see that you randomly selected and you randomly selected from here. And if you choose to again regroup this and this together, then again you can randomly select from these clusters also. So this is what is cluster sampling. So next, coming to sampling weights, which are also known as survey weights. So now that you're going to work with a secondary data set, secondary data sets tend to have sampling weights or survey weights because they are necessary for obtaining a generalizable estimate for the population. So these weights are based upon sampling, stratification, or non-response rate. So these weights are calculated based on the sampling, which could be different types of sampling, which we saw previously. They are also based on stratification, which means that if you're grouping the population into different strata, and it is also based on the non-response rate. So this is used so that this sample data represents the target population as closely as possible. So if you're selecting these kids from the classroom, then we have to be sure that whatever sample we are selecting from those specific classrooms is more closely representative of school-going children or school-going children of grade 1, 2, and 3. So this is the main purpose for which the sample data is collected, and we have to make sure that it does represent the target population. So over here you see an equation which is nothing but it shows you what sampling weights are and how are they actually calculated. So the W here is the sampling weight. So your sampling weight is equal to 1 divided by pi, and in the superscript you see there is an I here. So I is the unit in the sample and pi is the probability that unit I is in the sample, which means I is nothing but each case or each participant. So whenever we are calculating weights, so the weight is nothing but 1 divided by the probability that the case which we have selected in our study population is actually representative of the normal population. So this I over here is the case which is representative of the target population, and the I superscript in the pi that you see over here is the case which is in your own study population. So basically pi subscript I is the probability that I is in the sample. So there can be more than one sampling weights in a given data set. So you have to remember this, and I will talk more about this as we go further. And appropriate selection and application of weights is extremely important. So I will talk about this also. So coming to survey weights and sampling weights are interchangeable terms. They are used interchangeably. So survey weights, a value is assigned to each case in the data. So whenever we collect data, there is a certain value which is assigned to each case or each unit or each participant, however you would like to call it. We assign a value to it in the data. And this value, you have to remember, always it either has to be positive and it cannot be zero, because you cannot have zero participants in a study, correct? Or you cannot even have negative participants in a study. So it has to be a positive and a non-zero value for it to be a survey weight. And this value indicates how much each case will count in a statistical test, which means we have to assign a value so that we can gauge that each participant, how representative that participant is of the target population, especially when we are taking that particular participant or that value into consideration into a statistical test. So survey weights can be, and they're often fractions, okay? So remember this, survey weights are often fractions. So you will see 0.5, 0.6, 0.4, they will always be fractions. And survey weights are collected because they compensate for oversampling or undersampling of the population. So there are certain studies wherein there will be some populations that you're working with which will require oversampling of the population, or sometimes due to lack of resources or some other reasons there is undersampling of the population also. So in these cases, in order to correct this error and to not have any kind of bias in the study, it's important that we develop survey weights. So an example is if a survey overrepresents females in a population and underrepresents males, then survey weights can be used to compensate for this particular bias. So I'm going to talk more about that example as we go further. So there are two types of weights. There are design weights and there are the next weight is post-stratification weight. But first we'll talk about design weights. So design weights are used to compensate for disproportionate sampling, which means that we are representing one section of the population more compared to the other section. So therefore design weights are used. They are used when we want to study statistics which have to be more representative of the population. So whenever we collect data, we are collecting data so that we can analyze it, and analyzing data involves statistics. So therefore, design weights are used so that while doing statistics, whatever population we are working with and whatever results we are getting from that particular population are more representative of the target population. So give you an example, let's say in a study with a minority group, okay, there are minority group members, the sampling size was doubled from the minority areas or neighborhoods from where the data was collected. So oversampling is pretty common, especially with minority group population. So therefore, in this particular study where we are seeing this example, the sampling size was doubled wherever data was being collected from minority neighborhoods. So in this case, in this design where there was oversampling, each case from that particular area would actually get a value of 0.5. Why? Because we are oversampling the population. We are actually doubling the size of the population. So we are compensating for oversampling of the population. The next type of weight we come to is a post-stratification weight, which is also known as a non-response weight. So there are certain characteristics in a population which make them more likely to be related to the propensity to respond to a survey. So let's say age can be a factor. Like older age group people may have more propensity to respond to survey. When it comes to gender, it has been seen time and again that females are more responsive to survey compared to males. And it has also been seen that females tend to complete a survey more accurately compared to their male participants. Race, ethnicity could play a role, the education of the person could play a role, income, neighborhood, all these factors play a role when it comes to the propensity of responding to a survey. So, compensating for the fact that certain characteristics are not as likely to respond to a survey compared to others, this kind of compensation is used in post stratification weight, okay, which means you are actually stratifying that population based on their characteristics, which is related to their propensity to respond to a particular survey. So how do we calculate weights? So as I said previously, there could be that there are males and females in a population. So in this particular example, you see that this is your actual target population, which is your more representative population. And there are 50% males and 50% females. However, in your study sample, which you took from this target population, there were more uh, there were more females compared to males. Whereas in this, you can see that there were more males compared to females. So if you have to do a calculation of a survey weight, then you will see that the survey weight for males is 0.83, whereas survey weight for females is 1.25. So basically, this is how weights are calculated. And what we are doing here is we are compensating for this particular oversampling here or over representativeness of one particular group compared to the other, which is males compared to females. So this is an example. So let's say we have two types of weights in a study, which we are doing using a secondary data set. So you're given a secondary data set, and that data set has a design weight and it also has a post stratification weight. Okay, so both these weights are provided to you in the secondary data set. So for analysis, we may be required to combine these weights into one single weight. So when we are doing our analysis, we can actually multiply both these weights together and make a final weight, and we can use this final weight in our analysis when we are doing statistical analysis using SAS. And further, especially when you're doing any kind of longitudinal study, which goes on for years and years, and if you want to adjust for the number of years that you're actually doing that study for, then what you can do is you can prepare another weight wherein you can divide that final weight by the number of years that you are actually doing this study or the number of years of data that you're using for this study. This particular example, which is the last sentence or the last line over here, is very common in longitudinal studies, and it is most commonly also used in longitudinal studies. So this is just an example to tell you that how survey weights are calculated and how you can actually incorporate them when you are doing your study analysis. So that will be it. Thank you.